Hello everyone. Welcome to the playlist of PSC, SSC and UPSC training classes. In this session, we'll be discussing most important MCQs related to electrical stream. Let's move on. First question. Pushpull amplifier requires option A equal input voltages in phase, option B equal input voltage with 90° out of phase, option C an output transformer with a center tap in the secondary, and option D equal input voltage with 180° out of phase. Option D is the right answer concerning push-pull amplifier. Let us discuss more on push-pull amplifier. It is basically a power amplifier, and a push-pull amplifier is an amplifier which has an output stage that can drive a current in either direction through the load. That's one peculiarity. Now, the output stage of a typical push-pull amplifier comprises of two identical transistors, power transistors, either BJT or MOSFETs, one sourcing the current through the load and while other sinking the current from the load. That's a peculiarity. It contains a pair of active devices such as complementary pair of transistors. So these are the few peculiarity of push-pull amplifier. Push-pull amplifier is having low distortion, then high efficiency and high output power which are required. You can classify push-pull amplifier such as class A, class B, class AB, etc. Among these classification, class B has highest efficiency, almost 78.5%. Now let us see how does it operate. The signal to be amplified is first split into two identical signals 180° out of phase. Generally, this splitting is done using an input coupling transformer. The input coupling transformer is so arranged that one signal is applied to the input of transistor and the other signal is applied to the input of other transistor. As I told, there are two transistor pairs are required. Main advantages: number one, low distortion, then absence of magnetic saturation in the coupling transformer core. That is another advantage. Similarly, regarding the drawback, we need two identical transistors. That's a main drawback. Moreover, the entire system is becoming bulky. Because of the coupling transformer, the whole system is becoming bulky. That's another drawback. As I told you that there are two transistors which are required. One will be in PNP type and another will be NPN type. This PNP type transistor that will act as a push type and the NPN transistor that will act pull type. That is why it is known as push-pull amplifier. We can call this one as push-pull amplifier. Application of push-pull amplifier. It will be used in radio frequency system. Then you can use TV, mobile phone and computers. Then long distance communication with less distortion. That's another peculiarity of push-pull amplifier. Similarly, these are used in loudspeakers. Then radio frequency signals, as I already told. Now moving on to second question. One of the method to increase the frequency response of transistor is make base region as thin as possible, then employ graded base doping, dope the transistor as light as possible, then dope the base heavily. Among these, option B is the right answer. Employ graded base doping. Regarding option B, it results reduced base transit time and a high cutoff frequency. Therefore, it improves the frequency response. Moreover, we can observe improved common emitter gain. So that is regarding question number 2. Moving on to question number 3. In a class A amplifier, the collector current flows for option A more than half of the input cycle, less than half of input cycle, option C half of the input cycle and entire input cycle. Class A is basically a power amplifier. Regarding this question, that means in a class A amplifier, the collector current flows less than half of the input cycle. You can go for option number B. You can classify power amplifier as class A, class B, class AB and class C. There are a lot more classification. However, these four classifications are most important and applicable. Now let us discuss individual type of class A, class B, class AB and class C separately. Regarding class A amplifier, it will conduct, you will be getting the output for full 360°. That means amplification will be done for 360°. The output transistor of a class A terminology never turns off. That's the main drawback. So it results off, and we can say that efficiency is also poor. So this is the circuit diagram of class A amplifier. there is one transistor is required for this application. And as you can see, this is the input cycle, and as I already told you that it will conduct current over full 360 degree, so that you will be getting full output over 360 degree. That's a peculiarity. Moving on to class B amplifier. Here we need two complementary transistors. One will act as push, other will act as pull. So push-pull combination. That means each transistor device amplifies only half of the output waveform. That means one half or 180 degree. So that's the conduction area. Conduction area will be restricted to 180 degree. As you can see, we have two complementary transistors. Both will be complementary each other. You can see the waveform. So one will be positive, other will be negative. That means both are complementary each other. And if you look at the output, it will conduct only 180 degree. That means only half cycle. So that's a peculiarity of class B amplifier. Compared to class A, class B is having bit more efficiency. Why? Because it will conduct only in that particular 180 degree. Moving on to class AB type amplifier. It is a combination of class A and class B amplifier. Efficiency somewhat improved, almost 50% to 60% compared to class A and class B. Then it is mostly used as audio amplifier. Then conduction degree that lies in between 180 degree and 360 degree. So that's a peculiarity of class AB amplifier. Now let us look at the diagram of class AB amplifier. We should have two transistors which will be complementary each other. You can look at the input side. This is actually input cycle. Then output cycle, if you look at it, lies in between 180 degree and 360 degree. So that's a peculiarity of class AB amplifier. Now moving on to third type of amplifier, that is class C amplifier. Compared to class A, class B and class AB amplifier, it shows better efficiency. Almost 80% efficiency will be shown by class C amplifier. But it is not suitable to use audio amplifier. You can see the conduction cycle. So it will conduct less than 180 degree. So that's a peculiarity. So that's why it is not suitable for using audio amplifier. So any kind of questions can be asked regarding this classification. Moving on to question number 4. Lap winding is suitable for dash current dash voltage DC generator. It is concerning a questions related to DC generator. So we have two type of winding, lap winding and wave winding. So regarding the question, lap winding is suitable for high current and low voltage system. Definitely I can go for option A. So let us classify lap winding and wave winding, and let us discuss some points related to lap winding and wave winding suitably. Regarding lap winding, number of parallel path, that is equal to A is equal to number of poles, where number of parallel path will be constant for wave winding. You can observe the diagram of lap winding and wave winding separately. The number of brush sets required is equal to number of poles in case of lap winding, where number of brush sets required is always equal to 2, constant. That is regarding wave winding. Preferable for high current and low voltage application. So that I explained in the question itself. Regarding the wave winding, it is suitable for high voltage and low current application. Normally used for generators capacity having more than 500 ampere. If high current requirement, you can go for lap winding, where low current requirement you can go for wave winding. So that's a specialty. Let us talk more on the classification of this type of winding in DC generator, that is lap winding and wave winding. Now let us define what is lap winding. The coil is lapped back to the succeeding coil, so that you can observe in the diagram. Regarding the wave winding, the coil of the winding from the wave shape. As you can see, the winding will be just like a waveform. Then connection. The end of the armature coil is connected to the adjacent segment on the commutators. That you can clearly grasp from the diagram. Regarding the wave winding, the end of the armature coil is connected to commutator segments some distance apart. You can maintain. You can see the particular distance which I mentioned in the point. Then parallel path. The number of parallel path equal to the total number of poles in case of lap winding. But in case of wave winding, the number of parallel path that is always equal to 2, that I already explained. Let us call lap winding in terms of parallel winding or multiple winding, where you can call wave winding as 2 circuit or series winding. It will be having parallel nature and it will be having series in nature. EMF is less in case of lap winding and EMF is more in case of wave winding. Then regarding the number of brushes, which I already explained, number of brushes equal to the number of parallel path. Then number of brushes will be always 2 in case of wave winding. Similarly, there are different type of lap windings available, simplex and duplex lap winding. But in case of wave winding, you can say progressive and retrogressive type wave winding. Efficiency is less in case of lap winding, but in case of wave winding, it shows higher efficiency. Then additional coil. You can make equalizer ring in case of lap winding. In case of wave winding, you can add dummy coils. Then winding cost. Winding cost is too high in case of lap winding, but winding cost is comparatively less in case of wave winding. Then application I already explained. It is suitable for a low voltage and high current application, but wave winding is suitable for high voltage and low current application. Question number 5. A faceplate starter is employed for starting of dash motor. Among this, direct current series motor, DC series motor is the right answer. Then regarding faceplate starter, the direct current faceplate starter is an electrical switchgear that starts direct current motor by charging the ohmic resistance in the armature and excitation circuit. Nowadays, we'll be replacing all the conventional resistors by using thyristor switches. We'll be using thyristor control. It is most convenient compared to the conventional method. Moving on to question number 6. Zero power factor method of an alternator is used to find its efficiency, voltage regulation, armature resistance, synchronous impedance. Among this option, voltage regulation, option D is the right answer. Zero power factor method is one of the popular method for measuring voltage regulation for the alternator. It is an indirect method. Now let us discuss what are the different methods for calculation of voltage regulation in case of alternator. Basically, two methods are available. Direct load test. You can observe direct load test, and second method is known as indirect method. Regarding indirect method, you can divide 3. First one is synchronous impedance or EMF method. Second one is armature turn method or MMF method. And third one is zero power factor method or Portier method. Now let us make a comparison. Before moving on to the comparison, let us study what is a voltage regulation. The voltage regulation of an alternator is defined as the change in its terminal voltage when full load is removed, keeping field excitation and speed constant divided by the rated terminal voltage. This is the mathematical expression for voltage regulation. Actually, voltage regulation should be, the value of voltage regulation should be as minimum as possible. Now let us move on different type of classification. Let us look at direct loading. It is suitable only for small alternators. The rating which should be less than 5 kVA. Let us look at different type of indirect method. Which method of finding percentage regulation is called pessimistic method? You can mention EMF method. EMF method is also known as pessimistic method. It can be asked in the examination. Then for finding voltage regulation of an alternator, the method which gives most accurate result, that is surely ZPF method. Then one more important terminology, that is known as SSCR, or you can call short circuit ratio. What do we mean by short circuit ratio? It measures the stability of an alternator. Let us define short circuit ratio. It is the ratio of field current required to produce rated armature voltage at open circuit to the field current required to produce the rated armature current at short circuit. Mathematically, SCR can be written as the ratio between IF for rated open circuit voltage to IF for the rated short circuit current. So that's a peculiarity of SCR. So these are the general terminology you should understand. Moving on to question number 7. The forbidden energy gap for germanium is 0.3 electron volt, 3.5 electron volt, 0.7 electron volt, 1.12 electron volt. The right answer is 0.7 electron volt. Let us define what is a forbidden energy gap according to valence band theory. According to band theory, the gap between valence band and conduction band is known as forbidden energy gap. As the name suggests, this band is the forbidden one without energy. Hence, no electron stays in the band. So there is a gap between valence band and conduction band, that is known as forbidden energy gap. The forbidden energy gap for silicon is 1.1 electron volt. That is another question which can be expected. So band theory is most important related to semiconductor physics. Let's come back to question number 8. By into 27 is option A silicon diode for industrial use, option B germanium power transistor for commercial use, option C silicon Zener diode, and option D silicon transistor for industrial use. Option A is the right answer. Silicon diode for industrial use. BY into 27 is nothing but it is a silicon diode for industrial use. You can download the data sheet of BY into 27 directly. Moving on to question number 9. A typical value of induction filter for 50 Hz input is option A 10 microhenry, option B 100 millihenry, option C 10 millihenry, option D 10 Henry. It's a general question. So option D is the right answer. Now regarding the capacitor type filter. A typical value of filter capacitor for 50 Hz input is obviously 50 microfarad. These are the standard value you have to remember while doing the design of filters. Moving on to question number 10. In order to make an SCR of, it is necessary to make. SCR is nothing but silicon control rectifier. It is one of the family of thyristor. Option A, anode voltage less than breakover voltage. Option B, gate current 0. Option C, anode current less than holding current. Option D, none of the above. That means in order to make an SCR, silicon control rectifier of, it is necessary to make anode current less than holding current. Now let us discuss something about SCR. So you can go for this question, you can go for option C. Regarding the SCR elaboration, silicon control rectifier, it is one of the family of thyristor. It is having 3 terminal, anode, cathode and gate. So gate is a control terminal. So you can provide gate current to turn on SCR. You can represent the SCR by using 2 transistor model. TR1 and TR2 are the 2 transistors which are connected in this manner. So this is known as 2 transistor model. This is one of the most popular model in case of SCR. As you can observe, SCR is having 3 junctions. Moreover, it is having 4 layers. You can observe 1, 2, 3, 4. It is a 3 junction 4 layer device. Moreover, this is the characteristics of SCR. It is having 3 region, operating region. First operating region is reverse blocking region. Second region is known as forward breakover region. And finally, forward conduction region. Actually, this is actually the conduction region of SCR. The reverse blocking region means, so if you are applying reverse voltage continuously, finally, the saturation will be taken place and your device gets spoiled. So majorly, the forward conduction region is the operating area of your thyristor or your SCR. If you want to talk about the operation, you need to understand what do you mean by latching current and holding current. So let us understand what is a latching current and holding current. Latching current is associated with the on process, where holding current is associated with the off process. Moving on to definition of latching current. It is the minimum value of anode current required to keep SCR in conduction state even after the removal of gate pulse. Even though if you remove the gate current, the SCR will not be turned off. Okay, that is regarding latching current. It is associated with the turn on process. Moving on to holding current. It is the minimum value of anode current below which SCR cannot maintain current through it and turn off. So if the forward anode current maintains less than holding current, then thyristor will be turned off. If you remove the gate current immediately, thyristor never goes to 0 state. But in case of gate turn off SCR or gate turn off thyristor, one of the device that is known as GTO. In case of GTO, it is applicable. If you want to turn on GTO, you have to provide gate current. If you want to turn off the GTO, you can remove the gate signal. That is possible only for GTO. So GTO is also another member of thyristor family, like SCR. But in case of SCR, if you remove the gate current, it will not turn off. So that's a peculiarity. So you have to understand what is a latching current and what is holding current. This is most important for all the type of examination. If you are having any queries regarding those questions, you can put up in the comment box. Thank you for watching this video. Please share. You can subscribe this channel for getting similar videos. I have one more YouTube channel, that is Winners Capsule. It's typically for competitive examination. Finally, thank you very much for your kind support.